Good morning. My name is Jack Janssen from CWI in Amsterdam, and on behalf of all the authors I would like to present our contribution, A Pipeline for Multiparty Volumetric Video Conferencing, Transmission of Point Clouds over Low Latency Dash. The work presented in this paper was done in the context of the Horizon 2020 VR Together project. We are looking at the application area of teleimmersive applications, or in other words, shared virtual spaces with the inclusion of real live media. You should think of something like a shared remote holodeck where multiple people are together in one virtual space, but they're physically rendered in that space as well. One of the things that triggered our work here is that a photorealistic representation of the other users is much better than avatars because it leads to increased immersion. And the other thing that triggered the work is that by now the hardware has become affordable. So you can get 3D sensors and head-mounted displays and decent CPUs and GPUs. You can build a system for something like what we do for 2,000 to 4,000 euros. There are two main contributions to our work, and the first one is that we use point clouds as the representation of the volumetric data. That is in contrast to the more commonly used mesh representation. Point clouds consist of an unstructured space of XYZ coordinates and the corresponding RGB color information, and they have the huge advantage that they are low complexity. Because they are low complexity, there is a low latency in capturing them, and there is potentially a low latency in compressing and decompressing them, and that leads to a low end-to-end latency, which is good for conferencing. The downside of point clouds is that the data volume is rather high because there is no structure in the data, so that means they require a high bandwidth. And that brings us to our second contribution, and that is that we use Dash as the transport protocol. The advantage of Dash is that it allows you to do multiple quality levels and therefore adapt easily to bandwidth variations and thereby offset the large data volume. Usually WebRTC would be used for conferencing applications, but as is shown in the paper, it is possible to do low delay Dash, where you get the delays in the range of hundreds of milliseconds, which is reasonable for conferencing. Also, Dash has the advantage that we don't have to worry about natting and firewall traversal and all of that. And of course, Dash makes it possible to easily do tiling of the point clouds, so that you would download only the parts that are visible to you, and it would allow you to do multiple qualities of streams, so that you would download only the streams that are needed in the quality that you need them. But please note that in the current demo we will only show a single stream of point clouds at a single quality level. The architecture allows for using different tiling strategies and for using different bandwidth selection strategies, but these are not implemented in the demo as we will show it. The other thing that hasn't been implemented is the synchronization between audio and video and the interdestination synchronization. Again, the hooks are in the architecture, but we have chosen for this demo to show a cut down version of things. And finally, the thing that isn't included is an MCU. We believe an MCU for conferencing applications like this should be an optional component and not a central component, and by initially creating something without an MCU, it'll make it a lot easier to add an MCU later than to remove it after the fact. Let's first have a look at our architecture from a global level. In this picture, the central part you see is one client. On the left hand side you see the sensors and the head-mount display. In the center of the client you see the processing that happens. The next part that you can see here is the cloud infrastructure that we use to transmit the data, and on the right hand you see two other clients. The important thing to get from this picture is that all processing, and specifically all 3D and graphics processing, is done on the client side. The only thing that happens in the cloud infrastructure is setup of conversations and distribution. If we look at the client picture in a bit more detail, we can see that the top part is the transmission chain and the bottom part is the reception chain. So let's first go to the transmission chain. At 1, our capturer captures the images from 4 RGBD cameras, aligns them, fuses them, and outputs point clouds. These point clouds go to 2 places. First of all, they go to the local renderer for self-view, and that is needed so that if you wear a head-mounted display, you can actually see your own hands and feet if you want to. They also go to the compressor, where the first step that happens is that the point cloud is tiled into multiple sections, and then each tile is individually compressed into multiple quality level. So, as an example, if we had 4 tiles in our point clouds and we wanted to use 3 quality levels, at this point we would have 12 parallel compressors running. Each of these compressors would feed a dash sender, of which we would then also have 12 running in parallel, which would package up the data stream and send it to the central dash infrastructure. On the receiving side, we only receive the dash streams that we are interested in. So given the previous example of 12 potential dash streams, we would have only 4 dash receivers, 1 per tile for the required quality level, and it would receive the dash stream from the central server. It would send the data to the decompressor, which would decompress the point cloud data, which would decompress the compressed data back into point cloud data, and then it would be sent through the synchronizer, where the individual tiles would be resynchronized and would be synchronized to the audio, and then finally it would go to the renderer, through which you would see the other participant in the conversation. In the demo, we will be using a setup with 2 participants, where the first participant has a high-end setup consisting of a real 3D studio with 4 RGBD cameras, a head-mounted display, and a fairly powerful workstation class machine to do the encoding and transmission. The other participant will use a much smaller setup, which has no head-mounted display and only 1 camera, and so where you would have to navigate through the virtual scene by using the mouse. And the cloud infrastructure in the demo will be off-site. The participants in demo will be inserted into a virtual space that is pictured here at the top, and in the center and bottom you can see the view of the participants. So the center picture is the view of the participant in the big studio who is looking at the small setup, and the bottom picture is the view from the user of the small setup looking at the participant in the big studio. With the given setup, we have only done some very initial measurements, because really there is not much point in doing any measurements until the tiling and multiple quality strategies are in place. But what we are seeing is promising. It's the latencies are definitely usable, so that shows that using Dash for conferencing is definitely an option, and we think that while 10 frames per second or even 50 frames per second are not acceptable. We have enough options for parallelism that we can improve these. So now let me take you to the demo space so that you can see the system in operation. But let me first show you our demonstration setup, the one that we were going to bring to Istanbul, but unfortunately that was not possible. I'm standing here in our 3D studio where you can see the 4 capture cameras that will capture the local user, and you can see the head-mounted display that the user will use to see the actual scene and the self-view and the view of the other people. If we move on, then you can see here the workstation class PC that is used to capture the video and to render the scene, which is currently empty. If we move on, you see here our second setup, which consists of a fairly capable laptop and a single camera and no head-mounted display. In this setup, the 2 systems are placed next to each other, but actually the data is transmitted off-site, actually through Paris, France. So the point clouds from here are sent to France and sent back to this computer to be displayed, and those point clouds are sent to France and back to be displayed. And the same for the conversational audio. Let us now have a look on the system in operation.
Hey Alina, that's a nice blouse. Where did you get it?
Thanks. Thanks, Shashir. I got it at Hey Mom. Hey, those are some really cool shoes. Where'd you get them?
Oh, they're really old. I got them about 5 years ago. But also at Hema. Hey Alina, that's a nice blouse. Where did you get it?
Thanks. Thanks, Shashir. I got it at Hey Mom. Hey, those are some really cool shoes. Where'd you get them?
Oh, they're really old. I got them about 5 years ago. But also at Hema. Hey Alina, that's a nice blouse. Where did you get it?
Thanks. Thanks, Shashir. I got it at Hey Mom. Hey, those are some really cool shoes. Where'd you get them?
Oh, they're really old. I got them about 5 years ago. But also at Hema.